So we are going to, as I am mentioning a while ago, we are going to start our discussion on another topic, which is regarding stresses and strain. So basically, what we have now are the different formulas that we are going to use. So these are the basic formulas that we are going to use, wherein you have the stress is equals to load over area, wherein the value for S is the stress, the value for P is the load, and the value for A is the area. And another formula that we can have is you have PL over AE. Y is equals to PL over AE. Or sometimes, ang symbol na ginagamit natin dito is that symbol. Wherein this Y is the deformation. Y is the deformation. P is the load. L is the length. A is for area. A is for area. And E is for modulus of elasticity. So later on, we are going to apply all of those formula. So at any rate, let me share with you first the problem that we are going to discuss for today. Nakikita nyo ba itong PowerPoint presentation?
Yes po, ma'am.
Okay, so we have to solve two problems here. We're going to solve two problems. So for the first problem, we are going to solve first. The first problem states that we have a 30 meters long aluminum bar subjected to a tensile stress of 175 megapascal, and we are going to determine the elongation if the modulus of elasticity is 69,116 megapascal. Again, we have a 30 meters long aluminum bar subjected to a tensile stress of 175 megapascal, and we are going to determine the elongation if the modulus of elasticity is 69,116 megapascal. Stop my sharing. Let me go to this whiteboard screen. So according to our problem, we are given what? We have a 30 meters long aluminum bar. So we are given here the length, which is 30 meters. The aluminum bar is subjected to a tensile stress, which is 175 megapascal. 175 megapascal is the same as 175 Newton per millimeter squared. And we have the modulus of elasticity, which is 69,116 megapascal. Okay. So we have the length is 30 meters. The tensile stress is 175 megapascal. The elongation is 69,116 megapascal. By the way, the relationship of stresses to different equipment is that remember that all equipments are subjected to wear and tear. And that wear and tear is basically because of the various stresses that is created because of the application of the different loadings. So basta merong load, definitely merong stress. Okay? Stress is different from strain. Stress in a way is dependent only on the magnitude and how the load is applied. While strain is related or relative or dependent also with the time. So kung gaano katagal na nagkaroon ng load, kino-consider yun sa strain. Pag sinabi nating stress, it's all about the magnitude of stress. O let's say for example, parang isang 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 tao na humahawak sa something or dinadala niya ang isang object. Ang stress, kung gaano kabigat yung kanyang yung load na dadalhin niya, yung behavior niya relative to that particular bigat nung kanyang dinadala, yun yung stress. Okay? Pero when we talk about strain, habang tumatagal na dala-dala niya yung loads na yon, mas nahihirapan or mas nagkakaroon ng stresses. So kaya ang tinatawag natin doon ay strain. So yun yung pagkakaiba ng stresses and strain. Meron na tayong time element sa strain. Sa stress, hindi natin kino-consider yung time. So let's say for example again, ang isang tao meron siyang object na binubuhat. Ang stress, kung gaano kabigat yung object, depende dun sa capacity nung tao na nagbubuhat. Pero pag sinabi nating strain, kahit pa gaano kalakas yung tao na magbubuhat ng object na yon, habang tumatagal, na dala-dala mo yung object or yung binubuhat mo yung object, naapektuhan yung iyong mga muscle, di ba? So nagkakaroon ng muscle strain. Okay? So that's the basic difference of stress and strain. So if you are going to relate it to pag sa inyo sa engineering, kasi kayo ay related ang mga works ninyo sa mga makina, sa mga machineries, ang lahat ng mga machineries merong mga what? Merong mga spare parts. And all those spare parts are subjected to wear and tear. Bakit nagkakaroon ng wear and tear? Dahil sa sobrang tagal na ginagamit mo yung equipment, di ba? Or yung makina. Yung makina para mag-work, meron niyang mga loads. Let's say for example, makina ng sasakyan. Hindi naman mag-work yung makina ng sasakyan, hindi yan tatakbo kung wala siyang load. So basically ang load ng mga machineries, like for example, yung
Fuel.
Oo, yan. Fuel. Fuel is an example of a load para sa mga sasakyan o sa mga makina. So, ibig sabihin, pag sinabi nating stress, yung kapasidad ng makina na mag-handle o sumuporta ng mga fuel loads na yun yung stress. Pero yung tagal, habang tumatagal siya, yung makina natin, meron siyang mga spare parts na naapektuhan because nagkakaroon ng strain. So, merong other factors pa doon. Pero, in terms of stress and strain, ang pinag-uusapan lang natin dito is the magnitude ng load, yung dimension ng spare parts, at saka yung modulus of elasticity. So, when we say modulus of elasticity, nakadepende yan sa kind of materials. Kasi iba-ibang materials, iba-iba ang modulus of elasticity. Ang modulus of elasticity ng steel is different from the modulus of elasticity of a plastic material, di ba? Iba rin yung modulus of elasticity kung mga rubber material yan. Okay? So, because of the differences in the material used in a particular equipment sa mga spare parts, kasi merong stainless steel, merong yung cast iron, merong mga ganong klase na material. So, nakaka-apekto rin yun dun sa stress at saka sa strain. And also, aside from the load, yun, deformation. So, paano nagkakaroon ng deformation? Deformation is a result of stress and strain in a particular equipment. pwedeng magkaroon ng deformation, pwedeng humaba, elongation, or pwedeng makompress, nagsushorten yung equipment. Or kung hindi man equipment, I mean, is the material. Okay? So, kung yung spare parts, subjected siya, let's say, for example, sa change in thermal temperature, or meron tayong variation sa thermal thermal environment. Okay, 'di ba? Kasi minsan, kaya 'di ba sa makina, apektado 'yan nung pag habang tumatagal mong ginagamit ang machine, ang nangyayari ay subjected siya sa pagbabago-bago ng temperatura. Okay? Mas umiinit yung environment kung saan nandun yung mga machineries or yung mga equipment, mas naaapektuhan yung ating mga materials. Let's say for example, kung kung halimbawa ang material natin is steel, pagka umiinit, tumataas ang temperature, nagkakaroon ng elongation. Pero pagka naman nagkakaroon ng pagbaba sa temperature, pwedeng mag-shorten, pwedeng mas makompress yung structure natin or yung element natin or yung material natin. So, that's basically the concept on stress and strain. So let me go back to the problem that we have here. We are given a 30 meters long aluminum bar and it is subjected to a tensile stress of 175 megapascal. We are going to determine the elongation if the modulus of elasticity is 69,116 megapascal. So we are going to find, according to the problem, we need to determine the elongation. Or sometimes, ang ating symbol para sa elongation is Y. But basically, meron tayong ganitong symbol para sa elongation. This is elongation, and what we are going to determine is that particular elongation. So, nagkakaroon kasi ng deformation. Again, ang deformation either na-shorten or nag-elongate yung material. Okay? So, what are the formula that we can use? Going back to what I have discussed previously, there are several formulas that we can make use of. So you have the formula, basic formula for stress, wherein S is stress, P is the load, NA is the area. The basic unit that we are using for stress is Newton per millimeter squared or megapascal or Newton per square meter or that is Pascal or it could be kilonewton per square meter depending on the given in the problem. So unit for the loadings is Newton of course and the unit for area is square millimeter, centimeter square or square meters. So depending again on the problem. You will have to make sure that you are consistent with your unit. So if you are using Newton or mm, you have to make sure that all the elements are in consistent unit. And another formula that we are going to use is the formula for elongation, which is PL over AE, wherein this symbol is the elongation or deformation. P is the load. L is the length of the materials. A is the area of the materials. And E is the modulus of elasticity, depending on the kind of material. Again, I mentioned a while ago that the modulus of elasticity will be dependent on whether the material is steel, plastic, rubber, or whatever. So we have a varying value for the modulus of elasticity. So these are the formula that we can use. There are only two. And of course, you've got the formula for the area, which is dependent on what cross-sectional area are you going to use. The formula for the area, for circular area, what's the formula for circular section? Formula for area for circular section. Times height. O
Ma'am, with times
length
height. With.
times width. Area pa lang tayo ha. Length times width. Okay? Area yon. Okay, so area of circle is pi d squared over 4. Area for square is the length of one side multiplied by the other side. Dahil parehas lang naman sila ng side pag square, so it could be denoted as x squared or a squared. Pag rectangle, it's length times width, di ba? Okay. So, let me go to the solution kasi hindi yan yung problem natin, but we are introducing the different formula that we can use. In solving for the elongation, because this is the one in question in the problem, in solving for the elongation, we can make use of the formula for stress to determine the area. Diba? Since we are given the stress and we are given the length. Okay. So take note that the elongation is equals to PL over AE. And take note also that the formula for stress is equals to P over A. Nakukuha ninyo? Do you follow? Okay. The formula for elongation is PL over AE. Pakimute. Kanino yun? Pakimute ng microphone. That would mean we have y is equals to SL over E. So by direct substituting the value for this S or stress, 175 times 10 to the 6th, and then the value for E, which is 30 meters, and the value for E, which is 69,116, we will get a value for Y. The answer is 0.076 meters or 76 mm. Any question? So we shall go to the next problem. According to the next problem, we are given a steel wire, 6 meters long, hanging vertically with a load of 2,000 Newton. Neglecting the weight of the wire, we are going to determine the required diameter if the stress is not to exceed 140 megapascal and the total elongation is not to exceed 4.0 mm, assuming that the modulus of elasticity is 200,000 megapascal. So we are going to, again, pwede ko nang i-erase itong ginawa ko kanina. Is it okay with you? Okay lang sa
Nasulat
inyo?
na.
Pwede na?
Opo, nasulat na po.
Okay. So we are going to proceed with the next problem. So we have a steel wire again, and it is hanging vertically. So if you are going to illustrate it, let's say this is the illustration. Let's say and the wire is hanging vertically. It's subjected to a load of 2,000 Newton. So the load is 2,000 Newton. And the length is 6 meters. We are going to determine, kasi pag mag-elongate siya, because of the load, the tendency of the wire is to elongate. So this is the elongation. And according to the problem, the required diameter is not to exceed, the stress is not to exceed 140 megapascal, and the total elongation should not exceed 4 mm, or that's equivalent to 0.004 mm, where y is equals to 0.004 mm. Take note that was a conversion of the 4 meters. 4 mm. So that is 0.004 meters. So that's, we have, to balance the condition, P should be equal to F. And we have a cross-sectional diameter. We don't know the diameter. So that's the cross-sectional area. Okay. The cross-sectional area is a circle. So because we are given the diameter. Okay. We go to the problem. Go to the problem, and we are going to identify the various given data. What are the data which were provided to us? We have the length, which is 6 meters. We have the load, which is 2,000 Newton, or that's F. And of course, we have the weight of the wire is to be neglected. We are going to make use of 140 megapascal for allowable stress. That means the stress should not exceed 140 Newton per square millimeter. And the elongation should not exceed 4 mm, or 0.004 meters. Yeah, 4 mm divided by 1,000, that's 0.004 meters. And we are given the modulus of elasticity, which is assumed to be 200,000 Newton per millimeter squared. Newton or megapascal. Okay, so those are the different given data to us. And we are going to determine what? We are going to find the diameter of the steel wire. So for the formula, what formula can we use? Again, we have the formula for the elongation, which is equals to PL over AE. We have the formula for stress, which is equals to P over A. And since we have a circular cross section, then that means we are going to use the formula for a circular cross section. So what's the circular cross section area? Anong area na gagamitin natin? Area is equals to pi D squared over 4. Okay? Nagets nyo ba yon? Okay tayo doon sa mga formulas? Okay, so you have the formula for the modulus of, sorry, for the elongation, it's PL over AE. The formula for the stress, which is P over A, and the formula for the area is pi d squared over 4 because our cross-sectional area is a circle. Pero kung iba yung cross-sectional area niyan, iba rin yung magiging formula natin sa area. Okay. But according to this problem, we have a cross-sectional area of pi d squared over 4 because this is a circular section. Okay? So, we are given the deflection. Let us go to the solution. Let's go to the solution. You have the deflection. The deflection is PL over AE. It's PL over AE. And take note that if we are going to substitute the formula for the area, that is PL over pi d squared over 4 by E. Okay? Diba? So you have the value for P, you have the value for L, you have the value for modulus of elasticity, and you have the value for the deformation, di ba? So, pwede nyo nang i-substitute directly yon. Or, if you would want, pwede namang gamitin nyo muna is P over A. Hanapin nyo muna yung area. Okay, you are given the stress and you are given the load. You can determine the value for the area. Okay? So, pwedeng ganun yung gawin natin. Or you can directly substitute it here. Ito, area natin, formula for the area is pi d squared over 4. So, we are going to substitute. Take note the value for y is 0.04 unit is in meters. And that's equals to P. P is 2,000 Newton. 2,000 Newton. And the value for L is 6 meters. 6 meters. Okay. And then you have pi over 4. That's a constant value. We don't know the value for the diameter, but we have the value for the modulus of elasticity, which is 200,000. If we are going to convert this to Newton square meter, it have 10 to the 6th. Okay. So the value for D will be equal to, or you can determine first the stress times L over E. Okay. Okay, let us try solving for this one.